For this week's video, we will be talking about calorimetry. We will be doing two problems. The first problem says 75 grams of cobalt at 54.5 degrees C is added to 215 grams of water at 14.6 degrees C. If the temperature of the cobalt and water reaches 16.1 degrees C, what is the specific heat of the cobalt? So now we must figure out which species are going to be our losers, the high temperature species, or the gainers, the low temperature species. So we know that because the cobalt is at the higher temperature, it is going to be the species losing heat. So we can write that as negative Q of our cobalt. We will set that equal to the Q of our H2O, the species gaining the energy. This is an application of the first law of thermodynamics. So now we can substitute in our equation negative mc delta T, and in this case we will label the specific heat of cobalt because that's what we are solving for, and we will set that equal to an mc delta T of our water. Remember, the energy being lost by the cobalt will be gained by the water. So because we are trying to solve for our specific heat of cobalt, we are going to isolate out that variable. So we will have our specific heat of cobalt equal to our entire right side. That is the mc delta T of the water. So that will be the mass of the water, our specific heat of water, which is the one specific heat you are required to know, and finally our temperature change. Then we are going to have in our denominator our negative mass, carrying the negative sign from our losing species, and our temperature change of the cobalt as well. So now we must identify these variables. The mass of our water is in the problem at 215 grams of water. The specific heat of water is 4.184 joules per gram degree C. This is a value that I would expect you to know. Finally, let's look at our temperature change. Our final temperature is going to be the 16.1 because as we are adding the warm metal, the temperature should rise. So we will put in for our T final 16.1 degrees C, and for our initial temperature 14.6 degrees C. This includes all of our variable identification for our water gainer. So now we need the mass of our cobalt, but we might need to make sure to put the negative in front of that mass. So we have negative 75.0 grams of cobalt. And now we must determine the temperature change for the cobalt as well. Remember, we need to have the 16.1 be our final. Our temperatures should be equal for both the water and the cobalt in their final state. The initial temperature is going to be our 54.5 degrees C. We can put all of this information in a calculator, making sure both of our negatives in the denominator cancel, and you will get an answer of, for the specific heat of cobalt, 0.469 joules per gram degree C. In this problem, we used all of the identified variables to determine an unknown, and in this case, the specific heat of cobalt. For our second problem today, calculate the final temperature when 7.15 grams of aluminum with its specific heat at 73.6 degrees C is placed in 205 grams of water, which has a temperature of 16.3. So now what we need to do is itemize not only our gainers and losers, but calculate a final temperature for both species. So the species losing energy is going to be our aluminum. So this can be negative Q of our aluminum equals the Q of our water. Just like the last problem, we are going to end up having MC delta T equations for both species. So we will have negative MC, which is our aluminum, delta T, setting equal to MC delta T of our water. The left side being our loser, the right side being our gainer. So now what we can do is put in all the information that we've received from our problem. We have negative mass of our aluminum, so that would be 7.15 grams of aluminum, times the specific heat of aluminum, which is given in the problem. So that would be 0.892 joules per gram degree C. But now for our temperature change, we must itemize and distribute out our temperature final, what we're solving for, minus the initial temperature of the aluminum, which in this case is 73.6 degrees C. We will set that equal to the information for our water. So we have our mass of 205 grams. We will multiply that by the specific heat of water, which once again is 4.184 joules per gram degree C. And just like the left side, we are going to itemize out our temperature. So we will have temperature final minus our 16.3, which was the initial temperature of our water. Now we must go to the most difficult step of our math, and that is distributing out our various values. So if we take our negative 7.15 grams, multiply it by the specific heat and the temperature final, you'll get a value of negative 6.3778 temperature final. Then we can distribute those factors to our initial temperature and get a value of 469.4. Notice that both negatives will cancel. Then we can set this equal to the distributed values of the right side. So we can take our 205 and our 4.184 with our temperature final and get a value of 857.72 temperature final minus, and we can distribute those front two terms with our temperature at the end, and that is a value of negative 13,980.8. So now that we have these values, we need to collect our terms. We're going to bring the number part over to the left, and that will give us a value of 14,450.2. And then on the right side, we'll collect our temperature final terms. So we're going to add the 6.3778 term to the right side and get a value of 864.1 temperature final. To solve for TF, all we need to do is divide by our 864.1. If we do that, we will get a temperature final value of 16.7 degrees C. So even though we added this aluminum, it only went up by 0.4 of a degree. In this second problem, we wanted to make sure that not only we label our losers and gainers, but we needed to distribute the terms inside of our equation. Good luck.